So most of you know Watson. Maybe you're familiar with Sherlock Holmes, like that. That might be the reason, but there's another Watson who had a look at Jeopardy in 2011. Some of you. Watson was a very special candidate. I think he made it to up to $80,000. Is that right? Something like that. And Watson is not only for playing. Watson is something really special. And I know a person here in the audience that knows Watson better than I do, and I'm sure than most of you do right now. And she's the general manager, Watson IoT at IBM. And I'm really happy to announce right now, Harriett Green. Please give a warm welcome.
Thank you so much. Okay, thank you so much for having me here and giving us the opportunity to share IBM's perspective on Industry 4.0 and this amazing industrial internet. Now, IBM is delighted to be back at Hannover at this amazing fair, and here's why. Because we are entering an era of manufacturing that we believe will fulfill the true promise of Industry 4.0. We call it cognitive manufacturing. It's a kind of bold name. What is it? Cognitive manufacturing. It's what happens when you combine sensors, robotics, and data and capture the fourth industrial revolution with machine learning and advanced data analytics from Watson. It's what happens when we move beyond current connected capabilities, connected systems that simply gather data to industrial machines that use data to sense, to reason, and to action. And we're already seeing some staggering productivity results from this powerful capability. We're training Watson already with millions of images of products on the assembly line. And then with Watson IoT visual inspection, we can detect defects so very small that they are completely invisible to the human eye. And we can avoid costly production mistakes on everything from computer chips to car doors. In fact, we are already seeing a 10% reduction in manufacturing defects in tests of Watson IoT visual inspection. 10%, and in the early stages. And we're also using Watson to serve up decades of expertise, what we like to call tribal knowledge, from generations of oil rig engineers at Woodside Energy in Australia. If you've been to our booth, you've seen it there, helping them to bring new engineers up to speed, improve uptime, and ensure safety. And in a few minutes, you'll hear from Kone about how they are using Watson to keep a billion people moving on escalators and elevators every single day. And how this technology is transforming the very nature of a century-old company. It's all in the IBM booth. If you haven't been there, in hall number 7, I encourage you to see it. But it really is just a tiny glimpse of what is become, what is to come. Because we're all in the process, everyone here, of making history. We're using Watson, and we're using cognitive capabilities to really transform the way that we interact with the physical world. And in that process, we are redefining the way that we make, the way that we design, and the way that we operate the systems that facilitate life on this planet. To help me make this point, I'd like to announce an extraordinary new partnership between IBM and one of the greatest makers of our lifetime, a company that has completely created and transformed and pioneered industrial automation for more than a century, carrying the world from one industrial revolution to another. ABB and IBM are working together to usher in the new era of cognitive manufacturing. And we will be using IoT for manufacturing to bring real-time cognitive insights to the factory floor. And we're going to market together on a cognitive energy solution that will use predictive analytics to really help energy producers manage the supply chain and the supply and demand, actually, the whole dynamics of the renewable energy market. It's really cutting-edge stuff. And to tell you more about it, I'd like you to welcome Guido Jouret, the Chief Digital Officer at ABB. Guido.
Thank you, Harriett. All right, well, thank you very much. And we're very excited at ABB to be joining here with IBM. And the combination of what Harriett was presenting, the industrial expertise of ABB, the idea that we have 125 years of experience in the energy infrastructure and also in terms of industrial automation, first in process and more recently with our acquisition of B&R just a few weeks ago, now also on the discrete side. And where we see the power of these two worlds coming together is that a lot of our control systems are creating islands of automation. The ability to take an assembly line or to take part of a substation and to coordinate some of these increasingly digital assets that are there. But what we recognize is that we can't really unleash the full potential of automation unless we overcome some of these cognitive barriers. So whether it's quality control and inspection on the assembly line, or whether it's in the case of energy where we're taking into account so many different factors, things like the wind forecasts, the historical demand for power, the actual historical supply of power coming from various other sources. You have to combine all of these things and then make predictions about how much wind you're going to be able to harvest, how much baseload power you need to add. So that's a macro level optimization. And when we were looking for a partnership, it was very clear that although ABB has this domain expertise, that we really needed to look for a leader in the cognitive sciences. Because making these complex decisions, whether it's quality control or looking at optimizing these macro level problems, we saw with Harriett and her team a great partnership opportunity where we can combine an ABB asset with IBM Watson technologies and optimize this end-to-end. So adding cognitive capabilities with industrial automation. And that'll unlock these islands of automation and create an entire end-to-end stream where we can automate things from beginning to end. A combination of people know-how with automated systems that can assist and accelerate the decision-making. And so we're very pleased to be able to join Harriett and the IBM team here today and work together in a partnership to unlock the full potential of industrial automation. Thank you.
Hello. Thank you so much. And we're looking forward to this amazingly innovative work and to really redefining this era of cognitive manufacturing together. Now, all of you here know that to make great products, you first need a great plan. And that's where our friends in design and engineering come in. This critical step in the process that's always been kind of part art and part science. But in the cognitive era, we're starting to remove some of the mystery from the design phase so that engineers can work in a more informed, purposeful way. And let me show you what I mean with this amazing video.
We deploy bearings from very small bearings with 1 millimeter to 2 millimeters diameter to the very large bearings that are used in wind turbines. In the automotive business, here we have the full spectrum from bearings within the chassis to complex transmissions, up to e-axles and hybrid modules.
Industry 4.0 is getting the data real-time information structure in this supply and manufacturing chain.
Our bearing of the future will be a digital-enabled sensor, being part of the Internet of Things and being part of our value generation, which links bearings with more complex systems, with electronics, embedded software, as well as with additional services.
If we use IoT, we can be more flexible. So we can adapt faster, make decisions if something unforeseen happens.
We understand a lot more and allows us then to take actions on that in a way which was not known up to now.
So this is important for our own efficiency, for our own improvement, flexibility.
We think highly about delivering customer value. We think that a true partnership between Schaeffler and IBM will guide us into the digital age and help us to shape the mobility for tomorrow.
Schaeffler is using Watson IoT to inform the design of their bearings is nothing short of revolutionary. But it's only the first step. The company has already begun working with IBM to develop digital twins that really inform every step of their manufacturing operations from design to service. And we think these digital representations of physical systems are going to fundamentally change the way that engineered complex products are developed. By visualizing and manipulating digital twins, we can understand and manage systems more quickly and much more intimately. We can extend this management beyond design and manufacturing and into the ongoing, real detailed operations of the connected products. And with Watson, the data from digital twins, including unstructured audio, different images and video data, will inform decisions across the whole organization. It will feed insight to the whole kind of digital design process with the designers. It will spot defects on the factory floor, and it will enable true predictive maintenance. In fact, with Watson Digital Twins, we can really be assured that the entire digital ecosystem, the sharing of information, the provisioning of a single source across the entire value chain, which really is about this industrial revolution, the way in which products are really owned and operated. And in this era of cognitive manufacturing, insight well past the assembly line is key. Products that continuously and endlessly monitor their use, report on their own condition, and learn over time and change the way that we interact with the physical world. Like this.
Hey,
Pass, please.
I'm here to fix the elevator.
Nothing's wrong with the elevator,
Right,
but you want to fix it.
right.
So who sent you?
New guy,
What new guy?
Watson.
My analysis of sensor and maintenance data indicates elevator 3 will malfunction in 2 days.
There you go.
You still need a pass.
You still need a pass. I absolutely love that. This is not just a really clever and quite funny advertisement. This is real. It is absolutely happening today. Real-time analytics, predictive analytics, a total transformation of the way products are operated in real-world environments, and how they're experienced by our customers and our clients, and how we can build new services around these products that really differentiate us, give us competitive differentiation. Now, to tell us more about it, I would love to welcome to the stage Heikki Hasma, a Senior Vice President of Maintenance Business at Kone.
Thank you, Harriett. Thank you. That was a great video, wasn't it? I like it a lot. Great to be here, and thank you, Harriett. Of course, this is actually a really inspiring moment to see so many people from different industries in the same room. But okay, let's think first about what is Kone. I assume that all of you, or at least most of you, use every day our elevators or escalators. We operate in all parts of the world. At Kone, what we do is that we provide people flow. In practice, it means that we help our users to move in and between the buildings. Globally, what we do, we serve over 1.1 million elevators and escalators, and actually over 1 billion users use our equipment every day. So if we wouldn't do our work well, the cities would not work as they work today. But let's think about today. We have many different kind of customers. We serve construction companies, builders, building owners, developers. We start our approach from the customer's perspective. 1 year ago, we launched our cooperation with IBM, and this year in February, we launched our 24/7 connected services, which is a service using the IBM Watson IoT platform and helping to predict the elevator and escalator condition. What does it mean for our customers? It helps our customers to manage their equipment over the life cycle in much better ways. And do you know what? This is really a game changer in our industry. That's what I believe in. Our customer needs are changing all the time. Our customers are expecting predictability and transparency in all what are expected from us. With Watson, we are able to answer this one. We help our technicians to work smarter in the field. Current ways what we are using Watson is that we have the IoT and then the analytics. And with this, we are helping our customers with a totally new service experience. In concrete terms, meaning less downtime and less faults with our equipment. But this is just the beginning, and this is the best part. So what comes in the future? Watson can help us in troubleshooting for our service technicians and also our call centers. We use artificial intelligence, and that will help us or open new opportunities to work smarter in the field. Our technicians to make smarter decisions and more quickly. It also helps us to faster roll out new additional services to our customers and end users. We want to provide insights and value naturally for our customers, and I fully believe that with this approach we can be the best in our industry with the customer service. But now let's look still at one video, and we made this video because we wanted to demystify the technology behind our IoT, so really show value. Let's look at that one.
It's a signal sent from a sensor in an elevator. Another signal from another sensor, sent every other second. It's not just a signal. It's the beginning of a new era, of elevators becoming intelligent. An elevator used to be a silent box on a rope, and now it communicates, and we can listen and uncover things we've never known before. make intelligent decisions, know what matters from millions of different signals, and give meaning.
Land at 11 millimeters high.
Just once too often, I'll alert a technician.
For us, it means that we can predict and act, fix before breakage, tailor the perfect maintenance to an individual elevator. For you, it means improved safety, full transparency, and ease of mind, because if something would happen, we'd already know. Intelligent services for elevators and escalators are here.
Thank you so much, Heike. I mean, I love that video. It just simplifies it. And we're thrilled to be partnering with you on this amazing work. So thank you. So as you can see, Watson is already quite literally changing the world. This year alone, 1 billion people will be touched in some way by Watson through cognitive robotics. Through cognitive. Some will be robotics, some through cognitive ball bearings, some through cognitive elevators, as we've discussed today. And the most exciting part is that we're just getting started. All of us in this room, this massive extended room, are active participants in this journey. In fact, I think many of you here are architects of it. And through our work, through our innovation, through our creativity, we're getting to shape our history. We get to define this era of cognitive manufacturing. And we are very grateful to have the opportunity to work together with you to do just that. So thank you very much indeed. Thank you for our amazing guests. I think we do have a few moments for questions. I'm going to ask Guido and Heike to come up onto the stage and to see if we have any questions and a microphone from our wonderful maitre d'. So please, if there's anything on your mind to do with cognitive manufacturing or Watson or ABB or Kone, let us know. A man at the back who's very tall.
Of course, in the back.
Of course, at the back.
So,
you haven't had your exercise today.
Hi. Hi. Can you hear me? Okay. Thank you. So on Kone, I wanted to ask, you just started your collaboration last year. Were you surprised that this was delivering results so quickly? And second point, what do you think were the key drivers to those results?
Thanks for the great question. So firstly, of course, I think both IBM and Kone has high expectations for the collaboration. So in that sense, I would say that we have been meeting the expectations with this approach, and naturally, of course, are looking to even boost forward the collaboration that we have had. I think all starts with the great discussion about what we want to achieve together, and of course that there has been great support from the IBM side to our key initiatives, and that we have been discussing on a daily, weekly, and monthly basis, depending on the people. But anyhow, that's about it.
And as you've noticed, Kone and the team are Finnish, and so it's always very factual, very straightforward. No sort of West Coast or East Coast blarney here, so they're hard to impress. Any other questions? Sir, the gentleman here, just to get this 100 meters. Come on, Usain. Move.
Just briefly, can you sketch a few medical applications of Watson?
Well, that's not any of our forte. I'll say a couple of things, and then we'll connect you with the right person. But as you know, we have created Watson Health. We have taught Watson Oncology, and Watson is now on the wards in Thailand, in New York, in other parts. I think there are 14 hospitals where we are augmenting the power of doctors to get even better diagnosis. There's an amazing, it's called CBS 60 Minutes, and it's about artificial intelligence and the impact on health. So watch that, and then if you have more questions. Thank you, sir. Was there another question?
Hello, Eric Ruffet. Do you work with reference architecture models like RAMI or component E4O concept for apply Watson application or any kind of application?
So just phrase that again. Is Torsten in the room anywhere close? Do we use simulated models?
Yes, reference architecture models for organize all components, for organize all information circulation on. Do you use it when you apply Watson? Normally, the reference architecture models help to organize all components, all function.
Sure. So the power of Watson as it pertains to the Internet of Things is it's not just the structured data, the architectural organizations that we are used to. It is also the reams of unstructured data, the video, the audio, the smell, the vibration. In fact, the user case with ABB is a very great example of this visual power of Watson. So I don't know, Guido, if you would add to that?
Yeah, so quite often in terms of reference architectures, the foundation of some of the data that's coming is, for example, in our case, a control system, and that's following the Purdue architecture of 4 layers of industrial automation, of sensor data, local control, and the rest, right? So that's the foundation, and the protocols that are using to feed that are standards like IEC 61850 and OPC UA. So that's standard, increasingly more common. However, when it comes to connecting these things, as Harriett just suggested, it's really the sensor fusion of the structured data coming from our sensors and actuators, and then visual information to inspect the quality of the work that's done, and then trying to learn from that based on outputs, right? So we have defects, and then we say, okay, these defects occurred when these visual images were there, and this sensory data was there. Can we try to then predict when we have a bad quality output, and then correct for that, right? So part of the architecture is structured, part of it is not, and the combination is then, of course, what the Watson and ABB collaboration in this case, and of course for Kone, their own case, is needing to do.
And I would encourage you, there's an amazing ABB booth with some of its digital ability solutions, the IBM booth. There's security, an amazing car demo, digital twin. And you must have many more questions than the 3 of us could answer. One last question, the gentleman with the long arms. Oh, he's very tall, that's why. Thank you.
Makes sense now.
Yeah, it makes sense, absolutely.
I have one more question. You were mentioning you reduce the downtime of production system, whatever, by 10%. What do you think is the maximum amount of breakdowns you can predict? Is there any I don't know, maximum amount, let's say 80% of the breakdowns are predictable and last 20% are unpredictable, or what's your number there?
Do you want to go first?
Yeah, really good question. Again, I would say that at least we target that. Let's say that basically all of the breakdowns can be avoided. Of course, there are some technical or like some external reasons which we cannot avoid. Something that in our case, elevators, escalators, it might be because of the end users or because of the vandalism or something like that. That's something that we cannot avoid. But basically all which are due to the technical reasons, we believe that we can avoid.
Yeah, that's similar for us as well. We believe that ultimately the vast majority of outages, there's usually warning signs, and sometimes they're very simple to detect. Like it turns out noise is a very often a predictor, especially with moving machinery. You hear it, you start to get the early warning signs. Vibration is another one that's often the case. And then sometimes temperature. So sometimes you don't need very sophisticated sensors to detect an imminent problem. And of course, once you have a good model, you know just how bad it has to get before that breakage can occur. So we believe, as our colleague does, that a lot of these can be eliminated over time.
Brilliant. Well, thank you all so much for joining us. I hope you found it useful. And if you have more questions, you know where to reach us. To you, thank you.